state. Calculated by good.
Yeah, could you try?
Sure. So the current state can be calculated by a culmination of all the events up to that given point in time. For example, quintessential example being like your a bank account. I deposited some money, I opened up with $5, I had 3 deposits, I did 2 checks, I did a withdrawal, and I added some more money. You add all those transactions together, my account balance should be X based on what those transactions are, right? That's your point in time. That's how you can calculate with an event-based model. Again, with the state-based model, you just do a transaction block on that table and you mutate that data at each point in time. So for the example I'm going to do is based again on my book a little bit that I wrote for Pulsar in Action. It's about, it uses a fictional food delivery service, and so the data models will be tied to that. It's about, so you have all these different drivers, like an Uber apps, or it's called Gotta Eat. So you have like a food delivery network. Different drivers have their phone-based application. It's sending in every 30 seconds automatically. You're sending in a ping of where they are, location-wise, so we can figure out where they are, who to assign the orders to. And this would be this is what would happen in a state-based model, right? So you'd have a unique driver ID, a unique lat long location, and a timestamp of when that person was, and that's it. So it's a one-to-one. There's one driver, there's one record in the database. That's it. It represents his most recent position on the map. And then we use that information. You can again read it out the other side, and you feed it to the downstream consuming application. They have to hit that exact same database for millions and millions of consumers. So there starts to be some throughput concerns on that side to feed the drive that location for all that data on the consumer side for your mobile app. If you're the person trying to figure out where your food is, track it coming down the street, making the wrong turn, and all that wonderful stuff. Now, an event-based model. Again, with the same data source, again, use the purple and orange to represent the sequence of events, right? They're intermingled with one another. We store this in what we call an Apache Pulsar or other messaging system. There's a topic, you publish this information here. It comes in an order. There's multiple entries for both, right? And the most recent one at the top is the most recent position for the purple driver. And obviously one for the orange is the orange one, but you can put all this information back together in sequence, and you can sort of have a route of where they travel. And this information is more useful. Obviously, we can use the most recent data to feed the endpoint for the for the UI that's shown here, but you can also do analytics on this data set, right? So now we know what route they took, approximately how long it took to get them from point to point to point, if they took the best route and that sort of thing. So it's a much more rich data set, and it has a lot more utilization or features in that regard. So just to summarize some of the performance or characteristics between these two data models, right? So with the data consistency in a state-based model uses full ACID semantics. It's guaranteed to be consistent. Whoever, the writers that wrote that data and the readers are all going to get the exact same data. With an event-based, you're going to have eventually consistent reads. There might be some latency between the data. The readers are trying to read through that information and do the processing of those events to calculate the current state. And so there could be some, eventually consistent data latency trade-offs that you're going to make. The supported operations are shown here. You can do the full CRUD semantics with your traditional database. There are no deletes. There are no updates with event-based, right? It's just, again, you don't change, hey, my account balance minus $100. Instead you put an event that says minus subtract $500 from my event. Instead, you do not. So you record, it's an auditable audit trail as well. You know why that account changed, what happened. Everything is completely add only, create and read only. The rate performance is obviously much better on the event-based side. It's non-blocking, it's asynchronous calls. You don't have any sort of single lock on the table, multiple people trying to update and read the same piece of information from the same table. Eventually forms a bottleneck. You're trying to have high scale systems, internet scale systems, putting a database in the middle, it's going to cause it to crash and not work. Right. So event-based model is sort of the future. If you want to have highly scalable, resilient data structures, event-based is the way to go. Read performance varies. So if you want point in time, if you're doing a query with an index and you know exactly what data you're looking for with a database, it can be very fast. But with event-based, it's going to be slower because the data is spread out over multiple events. So if you don't know exactly what you have, or you haven't pre-computed it, you have to go back to that sort of event source and scan all that information and calculate it on the fly, right? So again, go back to the database, the example where you're doing your account balance calculation. You want to know what the balance is for this account. In the database, you'll have it instantly. If you don't have it pre-computed on an event-based side, you have to get all this information, filter them out, and calculate that thing on the fly. So it could take longer. The benefit is some of the other benefits are evidentiary data, right? So all the data is retained with an event-based model. So again, as I mentioned, you know why every change to that table occurred, right? I added some records here. I had to subtract $10 from this particular order. Well, why was that the case? Because I applied a manager's discount. It doesn't just magically, get reduced by $10. We go back to audit the information, say, well, why do we charge this person less money? And you don't have a record that says, hey, by the way, this manager decided to do a discount of $10 on this particular order, for example. To have that information, there's evidence there. So there is no malfeasance under the covers. Everything squares up, and every change of state has an associated record with it that creates an audit trail. And then you can have replayability, right? So if you needed to, if the entire database went away, and you needed to, or you wanted to start at a point in time, and what was it last week? I put in a bad code change, and all the data was calculated after that because it was the old office space. I did it by a factor of 10. I computed the thing wrong, and all your transactions are now wrong. From that point forward, you can't go back and recalculate it if in a traditional database because you mutated your single source of data. With an event-based system, you can just go back and reset your data point to that point in time, rerun the records through the right algorithm versus that algorithm, and have clean data again. So there is replayability as well. So it's very easy to recover from as well. There's a lot of benefits of event-based data models. Now, so obviously event-based is the prequel to event sourcing. Martin Fowler is one of the people attributed to defining this term, and so I'll just put his quote up here. So since I'll let him define it himself, basically saying all the changes to the application state is recorded as a sequence of events that goes to the event-based model, and then you use the event sources to recalculate your database under the covers for all your different applications. Right. So event sourcing is just a pattern that uses the event-based data model we talked about to store data in a append-only log. Right. So the events come in, you store them in a Pulsar topic, and each fact that takes place within your business or application is represented as an event. Order placed at this point in time, driver moved to this particular location, a customer received the order, credit card was accepted, et cetera, et cetera. Those are all just a sequence of events stored in individual topics for each individual event in your business logic as well, and that's what's stored there. Now, when you want to go back and figure out, okay, this is just the raw data, right? So on top of that, you have the concept of like you would in the other database. I want to actually read this data and do some queries and do some analytics on it and know, again, like to feed my user interface, to do some analytical queries on it, like how many orders did I sell this hour, last week. Then you have the concept of materialized views, which is just a different way of looking at this same event stream based on how you want to consume this data and map it to your own particular database or microservice or a cache. They can each have their own independent and individual schema and still be fed by those same raw events. So an event, they might pluck some data off, for the cache might just have some, very minimal set of data characteristics, and you keep that information. The microservices might only be interested in another subset of that data set and calculate that and put it inside its internal database. But then your more analytics one might want to join it as well, grab some other information to do some more rich data sets on that. So it becomes a single source of truth that can be read, it's basically written once and read many times and in many different ways. And there's different ways of having these materialized views. Now, some of your different implementation options, again, to implement these materialized views are just the the processing engines themselves that you put on top of these, right? So you have multiple topics, all could be related to one another in some way or another. They're just a structured data. Data's coming in. There's some static data. There's some new data coming in. And you want to take this information and transform it and do some enrichment on it. You can do different things like a traditional SQL engine. You can do it with application code, or you can do a stream processing engine. Those are kind of your options for all of your different transformations and enrichment information. Again, you want to take these raw events and turn it into something that looks more like a traditional database. And so you can do point-in-time queries and have some analytics, some information about the state of your system. Now, obviously, once you process this information, the best practice is to do snapshots and store this information into a storage layer as well. So you can put that information, you do a checkpoint because obviously these events can be, if you never throw away the data, it can be very, very long, it can be years worth of data, it can be, billions and trillions of events. So a lot of a good strategy is to do a calculation up to, event 1 million, do a checkpoint to say, this is my value at this point. So if you need to reconstruct it at that point in time, you can cursor ahead and just, pick up from the last place you left off, like a database backup. And then you can replay it like a change data capture log on top of that to replay the most recent events as well. So very similar model as well. So let's talk about the command query responsibility separation, the longest term in the entire slides. Basically what we're saying here is that you want to separate the responsibility from the entire read path from the write path, right? So you want to have fast and scalable write-only operations. So again, I want to publish an information, the event comes in, I publish it to one of the topics or one of many topics, right? You're not blocking on an individual database. Those records just immediately doing a pen write. That's it, you're done. You can do as many of those as you want. It's highly scalable. On the read side, again, you want those to be completely independent and as well, and you don't want them going to the same data source as far as having an individual lock table again. They have their own way of reading these queries, reading these events. And then so this allows you to have full integration. It's unlimited number of integrations possible across these topics. I can add information from multiple topics in multiple different ways. And it's just event-based and it's loosely coupled. So there is no schema enforcement across each one of these. Every query can have its own schema. I read the information the way that it wants it to as well. So just realize I'm halfway through this and I have the wrong slide deck. That's okay. On this, I will switch on this and get into the event sourcing. So when you want to use event sourcing, right? Event sourcing is when you want to capture the intent, purpose, or reason in the data itself, and you don't want to be confined to a single schema itself. Or you want to capture the fact something happened in my system, right? In my case, we're talking about a driver moved from point A to point B, an order was placed, a credit card transaction was authorized, and you have that. This is what happened, and then you can always go back at any point in time and reconstruct a different version of your database based on those raw business events. You can add additional information for that. By doing so, you create a complete audit trail of all the changes in the system. Everything that came in, everything that went out, you have full auditability, visibility into everything that ever happened in your system. So you have a complete, you can go back at any point in time and answer any questions about why is this balance this? Why did we not pay this person that? Did this person get their order? What time did they get their order? Where was this driver at time X? We have all that information. We didn't override it with other data. We have all that information. Typically use it when it's a natural feature of your application itself. So when it requires little additional effort, when you're not trying to force it. If events are a natural language of your system itself, then it becomes a natural good fit. There's some cases where this isn't always the case, but generally you can map your business events to events themselves, and it becomes very natural to map into that. And then again, as we mentioned, flexibility, right? So you can change the format of these materialized models and entity data on the fly. So again, microservices is a great use case for that. It has a principle that every different microservice has its own version of the database so that they don't cross pollinate their schemas. And then if you have to change one, you have to change the other. Event sourcing feeds that use case very well because you say, here's the raw events, reread them yourselves and put them into whatever schema you care to put them in. And this microservice over here can do the same thing. It also has a benefit of it can start up fresh, and since it has no memory, it can read all the data once and get its database and schema up to the way it wants it to be very easily as well. So let's talk about the implementation of this, the demo I'm going to use. So again, I have a user interface. I'm going to demo here, hopefully, that has the end user has a mobile phone that they can sort of track their individual. They place their order in the food delivery app, or I'm going to show when they sign in, it shows around where their geolocation is. So these are the drivers that you see in your location. All this information that's based on the driver tracker service. It has a track driver view. It has a track drivers by grid ID. Grid ID is just a way of sort of limiting the scope of where this individual user is. There's an open source library by Uber they made available that basically has these hexagon regions, the map to way to encode lat long locations, and those are called grid squares. So a user comes in, we take their lat long, we put them in a grid, then we just grab that information from the grid of all the drivers that are there moving in and out. We also have a analytics view of the UI laser. That's the second one there, showing you if you're the end user of the Uber Eats application and you want to sort of look at your heat maps of where do we have our drivers located in the city as well. And so we can figure out where to place them, right? Because we can go back to what's our surge pricing. This region has a very high density of drivers we don't need. This region over here has nobody. We probably need to get some people over there so we can do these analytics as well. And then the last but not least is then just the driver location services. The driver itself is keeping track of where they are. It's in that information. And I just want to point out, these are all fed by a single event called driver location events, which is that this is my ID, this is my latitude, this is my longitude. So the most simple, basic, event model you can have is going to feed all these different use cases very nicely. So the first position here, just to mention, is the update driver position. Again, as I talked about at the very beginning, every driver in the fleet has to sign up to get their own Uber apps, or there's my fictional one, food delivery service, mobile app version. By default, this is going to send their update position every 30 seconds. So we know where they are. They agree to that when they sign up. It sends us information using their location in their phone, sends that information over. There's a command handler that generates this event and puts it into our event store, does some enrichment on it. We just say, okay, what hexagon grid is this? Boom, publish it into our topic. Everybody can use it. That's what the command handler does. That's the additional data enrichment process that it's doing. So the first view I'm going to show you is the, again, this is where I know it's not the right slide deck. It's going to be not the assigned driver location, but it's going to be you sign into the location itself, and it shows you all the drivers in your location, right? So it's still driven by there's going to be millions of these running concurrently. Every end user customer that signs into the app says, I want to order some food, or think of like you go to your Uber app, and you're trying to figure out where my drivers are, and I'm trying to order a ride. It's going to show you all the drivers in your region at that point in time. That's all going to be fed by that. So you look and say, okay, how many drivers are here? I can have an idea of how long I'm going to have to wait for somebody to show up. Right, and this is done by using an exclusive subscription. We call Pulsar's exclusive subscription, which means I'm reading every single record in that particular topic, and I'm filtering out by the driver ID itself, or in this case, I'm filtering out by the region ID because it's in the region I'm already mapped in. The second one I'm going to show is like a heat map, something similar to this. I don't generate enough data on my laptop to do something like this, but this is what it will do to help customize just, again, driver placement. That's the use case we're trying to solve for analytics. You sort of assign a range, the number of more drivers you have in a region, the darker red that region becomes. And then if you want to look at this in real time, it's just a map of the grid IDs shown as the number of drivers located within that grid, and then translated into a color map based on the number of drivers in there. Right. So again, we're going to use a reader interface, which goes back at a point in time every minute. So and then just calculate that, go back in minutes and recalculate that data every time. So every so often we're just going to scan that incoming topic, that location data over and over again, recalculate this information, and upgrade the display. So just wanted to know, I'm going to go through this demo now. The code is available here on my personal GitHub. It's gotta eat-ui.git. Again, it maps a bit to the code of my book that's available. Let's try to get this guy out now. I can't see my screen. There's nothing here. Sharing the screen. I shared, but nothing showed up. So let me share my desktop.
Yeah, try the entire screen. Yeah, it's good.
Okay. Thank you for that. How are we on time? I haven't seen the flashcards. Good on time.
You got minutes.
Okay. All right. So again, this is the Got a driver UI. I put 4 submodules in here. So this is where Quarkus comes in. I mentioned Quarkus. Those of you who came for Quarkus, you're not to be disappointed. I apologize. I wasn't false advertising on this, but we'll go ahead and start. There's 4 different parts of this, right? So the driver location service is the first one I talked about. This is REST endpoint, again, published in Quarkus. So I can go ahead and show the code. It uses the REST. That's beam information. You have to use the repository, use the service semantics that you do with Quarkus. Quarkus is it's a open source Apache project that allows you to minimize your JVM code and run it as a Kubernetes, completely containerized application. So you don't have to run it as a process. You don't have to upload the jar and all that sort of thing. You put up on a process, put it inside a Docker container. With Quarkus, you build this application, it becomes a pod itself, and you can deploy it automatically. So you can have redundancy and scalability in a cloud native environment as well. And so it's very annotated, friendly on this. I just want to show that we have a producer, which is a Pulsar implementation. So it's listening for information coming in on this endpoint here. So look up here. Sorry. Who's this? Who's this? And all the configuration stuff. Repository. Well, so it's listening on this endpoint. When it starts up, it goes and it gets the information first time, reads the information, and gets all the current locations using the Seek API. So you can go back and immediately read this information from the driver location service and get all this information and give you a list. Gets it by the driver ID. Again, this is all just using the list and filtering. So I'm reading the raw data from a topic and I'm filtering it here. So I'm just doing some filtering, very basic event sourcing, but it's simple to do with this information. Now there's a publicly exposed endpoint. When I get to record information gets called, it's going to write the information to that topic. This is what feeds everything. So I'm going to go ahead and start here. So I'm going to go ahead and start Apache Pulsar running locally. Apache Pulsar is a distributed enterprise messaging system. You can publish data to it as a concept of topics. It has infinite retention. It's completely decoupled and infinitely scalable. It came out of Yahoo. Think of it like RabbitMQ and Kafka got together. So you have the messaging semantics of RabbitMQ, plus you have event streaming, plus you have infinite scalability as well. So again, we have Pulsar up and running. Next, we'll go ahead and start. This is the driver location service. And again, we started with the Quarkus command here in development environments and started it locally. There's a compile command with Quarkus. You can set it for deploy and build an artifact, and it will just give you something that you can deploy in the Kubernetes environment. But here I'm just going to run it locally. Hopefully everything comes up and running on this information. So this is the endpoint that I just showed you. We're listening for events coming in. When a new event comes in, I publish a new message to the topic. I record the event time. I put the driver ID as the key, and I take the enriched value, which is, again, I've basically taken that lat long that has been published, and I've done through the Uber library, this grid location lookup. Being it takes this H3, what they call the H3 open source library by Uber, and just does gets the grid ID based on it, passes it in, gets it back out. It gives you a grid ID address, and that's it. That's all this code does. Very simple code. It's going to do all that information. Hopefully it's up and running. Okay. Number 2, apologize for the smaller font. Next step is not that interesting. It's just a driver simulation stuff. I'm basically simulating 8 drivers right now, publishing to that endpoint. They're randomly picking some information on that stuff. So I'm populating this topic with data. We should see some information to this effect coming in. The first service, we're seeing some data is getting published there, right? So I'm getting driver position signals are coming in. There's 8 of them. There's 8 drivers out there somewhere on the system running around publishing information to this topic. So now let's go ahead and start the first one of 2 demos, which is going to show you the position, right? So this is the use case where you open up your phone. Okay, I know I'm in this particular grid location, and it shows you a map. Okay, that's fine. I don't care about that error. I'm not in debug mode. Scared me for a minute. That's okay. All these things. Too many. And so this is my lat location. These drivers are starting to show up. These are the 8 drivers showing up on the map. And they're going to start jumping around as new events coming in, right? This is not true to life data. I'm kind of grabbing random lat long so that they look more like helicopters than cars because they're going down off the road. That's okay, but it's basically showing you that there's live data. And we're taking it in real time and mapping it back to a map graph information of that, right? So this is showing us all this information. This is being, again, fed by one data source with the lat long information, and that's it. That information, that service is called this tracker WebSocket. So I use that as a backend to this React.js application that's calling this, getting all this information here. Come on, show us the code here. Abstract one, driver tracker information. Look for this information. Again, if we're looking for, we just listen on this particular event. So we're consuming from that exact same topic. If it contains the key, which in our case is the grid scale where we're looking for, we get that information and we return it and we publish it out on our WebSocket to this web application. So every time an event comes in and this driver's there, we get that information, we pass it on. And then on the user interface, we update its position on this map. This map is also, it's available. I didn't write this, but it's a JavaScript library called Leaflet. It's readily available. If you want to do cool things with this, this is very cool. Most of my time was actually spent learning this JavaScript library rather than the code itself, as you can see. Now, the last thing here I want to start is the analytics service I talked about, which is going to show me a sort of a clustering of this information from an analytics use case. As well, again, going to be consuming all of these, again, that one single topic to get this information coming in. And this is basically handled in this particular location analytics repository. Again, it's a Quarkus application. It's going to listen to this information and it grabs a reader on that particular topic. It grabs, while there's information available, it grabs all that information, grabs it from a cache. And so we're recalculating the number of this. There's a number, right? We go through and read this information, look at the lat long, get the grid square, and then we just do a +1 for every grid square in there in this particular cache. We put that value back, and that ends up in turn feeding this particular graph interface here. This works. It's very dense because all of my cars only started at 8 are in this exact same region. Same part of Chicago. If I zoom out, it would be exactly the same. I'd have to generate some more load to do that, but as you can see, it kind of maps. Everybody's in this area, so geographically, everybody's in this area. When I run it with 50, you'll start seeing more different, calculated based on where they are. But this is updating it in real time, changing this information based on where they are. So I think I got the 10-minute warning. So I will stop there. The code again is readily available and see if anybody has any questions at this time.